All right, we're going to be graphing logarithmic functions now. For lack of a better term, I'm going to say the old functions that have to do with exponentials, and the new functions which have to do with logs, right? The old function, you remember the points with exponentials, we had 0, 1. Well, the new function is going to have 1b. I'm sorry, 1, 0, right? The old function was 1b, right? The new function is going to be b1. So you can see there's been a shift in our critical points. Not only these is log the inverse of a exponential function, but you can see that the x and y of these kind of critical points that we're talking about are also changed. So let's list them in our notes down here, right? So instead of having 0, 1, we have 1, 0, right? Which literally means the same thing backwards, right? If my answer, if I put in 1 as an answer to an exponential function, that exponent must be 0. So nothing else has changed, right? Every time I deal with this one, every single time I deal with that one, I am still shifting it using h, because the only thing up here that changes our x value, other than b, which is going to be, again, kind of solid down there, we're not dealing with b, only a, h, and k, is h. When I deal with this 0, now think about this, every time my y, I'm going to say this twice, every time we change our y, we multiply by a and add k. Every time I change my y, I multiply by a and add k. Well, a times 0 is still 0, and if I add k, it's just k. So there's one point changing, right? The other point, all right, remember it used to be 1b, and now it's b1. All right, so let's change this. b, we add h. That's the only thing we do the x's in these last two functions, the exponential and logarithmic. This 1, we multiply by a, so 1 times a is a, and then we add k. Well, those are going to be our changes. So let's use these down here. We'll use these to graph. Down here they're showing the parent function, all right? And let's see what we're supposed to do. Identify the asymptote. I'm just going to put a little h here, because now we have a horizontal asymptote at h, right? Find the reference points. I'm going to do 2 points, all right? Make a table 2 to 3 points. We're just going to do that. We're going to skip the table and do our reference points and graph it. Then we can do domain and range when we're done. Let's do it. All right. So I'm going to come up here and list them all. So we got a equals -2. It's right there. B's kind of sneaky. He's hiding way down low. B is 2. All right. H right here is 1. And k equals -2. So we've got all those values. Remember this h right here. This h right here gives me my new asymptote, which I'm going to draw in. Right. There's my asymptote of x equals 1. And let's change our points. So there's the parent graph. You can actually see there's 1, 0 right there. So 1, 0. I'm going to write below what happens, right? 1, 0 turns into 1 plus h, and then just k. So 1 plus h gives me a 2, and k is -2. So this point right here went to 2, -2. And if you think about it, right, that makes perfect sense. I could talk about in terms of stretches, but you know what? In the interest of time, I'll point this out in class, and we'll just keep going from here. And we also have another point that's b1. Let's think about what happens to b1. This turns into b plus h. And you know what? I'm going to erase that b. Let's actually put what our base is, 2, 1. So that turns into 2 plus h. And this 1 turns into times a plus k. Let's think about it. So I've got a 2 there, and we're saying 2 plus h, so that gives me a 3. All right. We've got a 1 there times a, -2, pointing up here with my left hand. And then plus k gives me a -4. So I've got 3, -4. Right here. We can see it. There's our asymptote. So we go towards the asymptote like this and go away from it like this. We've done our graph. In terms of range, it's going to be a little bit different now. I think they said set notation. So our range, right, it's going to be we'll say y. We could say f of x here as well. Is going to be, what? Negative infinity is less than y, which is less than infinity. There's that. Let's do domain. Alright, so domain is x. Looks like my domain goes to about 1. 1 is less than x and goes all the way to infinity. Done. There's 1. Alright, finished. Not too bad, right? As long as you remember these critical points and the same parameters change them. H changes the x value, right? A and k change the y value. So let's list our A, B, H, K over here. So we got A, which we can see is right here. Right, there's 2. We've got H. Uh-oh, hidden H, right? This common log we got right here has a base of 10. Whenever you don't see it's a base of 10. Oh, you know what? That's a hidden B. So let me write the B. I'll put it right here. B is 10. H is right here is negative 2. And K right here is 4. Let's do this. We'll take our 2 points. So here's our 2 points. Right? We've got 1, 0. Alright, that really turns into 1 plus H. And then K. Let's do it. Which is 1 plus H is negative 1. And K is 4. Alright, negative 1, 4. Let's do it. Negative 1 over here. 1, 2, 3, 4. Right there. You know what? Let's do our H and get our asymptote in here. I'm just going to draw it in here. There it is, and that's x equals negative 2. We'll go from here. So remember the next point. This is a tough point, right? It used to be 1b. Now it's b1. We'll put our b in as 10 and say 1 right here. Remember how that changes, right? This x value, though there was b, that's going to be 10 plus h. And that's 1 times a plus k. So let's do it. 10 plus h. 10 plus h. That gives me 8. Alright. A plus K. A plus K. Looks like 6. Looks like we got a point that's 8, 6. So I go 8. And I go to 6 right here. And I graph it. And I hug this asymptote. And I go on forever in that direction. Let's get our range. Which is again all real numbers. And domain, which again is, oh wait, I said again, so let's find our domain. Where does it end at? Negative 2? Negative 2 is less than x, which is less than infinity. Alright, got one more. I'm going to hit this guy with you. And here we go. We got our A, which looks to be 1/2. We get our B right down there, still our base. It's 2 hidden down there. H equals negative 1, K equals 2. Okay. With this, we're gonna do our changes. Let's get our asymptote first. H is negative 1. Looks like right here. I'm gonna draw it in. I'm gonna name it as x equals negative 1. New asymptote. We'll change 1, 0. Remember that is 1 plus H and K. Well, 1 plus H is looks to be 0, and K is 2. So I got a point that's 0, 2. We're going to put it right here, 0, 2. And then we got, used to be 1b, now it's b1, and it looks like b right there is 2, 1. So remember that's going to be 2 plus H. 1 times A is A plus K. So let's see, 2 plus H is 1. A plus K is 2.5. So let's put that one here. 1 and about 2.5. Once again, we hug the asymptote, and this starts to go up like that forever. We're good. Look back over this. Make sure you understand it. We're going to keep going.